Hello, Algebra 1. We are going to be putting together a bunch of concepts that you've already learned and combining them into one greater concept. And so this isn't really anything new. We're just synthesizing or putting together what you've already learned. And so the title of this is going to be slope-intercept form. Intercept form. Slope-intercept form. And slope-intercept form is the quintessential Algebra 1 concept that you will learn, that you will use on into the rest of your math career. I remember sitting in my middle school algebra class and learning slope-intercept form from Mr. M, my math teacher. So it's an important one. So what we have learned is we've learned, first of all, what slope is, right? You've learned that the slope of a line is the steepness. And so depending on how steep it is, the slope is going to change. You also learned that as you're going from left to right, if you go uphill, then it's a positive slope, right? These are all positive slopes. But if you go downhill, you have negative slopes, regardless of how steep or how shallow that is. As long as you're going downhill from left to right, those are negative slopes. Okay, so you've learned that. You've learned that slope is expressed in a fraction. And so slopes can be 2/3. It could also be an improper fraction. It can be 3/2. It could be a whole number, but that whole number just represents a fraction over 1, right? The whole number over 1. And then, of course, down here, that'd be negative 2/3 or negative 3/2 or -4, which would be -4/1. Okay, so you guys have learned what slope is. You have also learned how to find the intercepts of a line. So I'm just going to roughly sketch one in here, and that was supposed to cross right there. So we'll just pretend that it did, okay? So you've learned how to find the intercepts. On this one, the x-intercept, is -2, right? Because it crosses the x-axis at -2, and the y-intercept right here is +3. Right? Okay, so you have learned slope and intercept, and now we're going to combine those. As I said, this is called slope-intercept form. Okay, and so what slope-intercept form is it's the equation of a line given in this way. Y is equal to mx plus b. Y equals mx plus b. Anytime you have an equation in this format, it will produce a line. And so what these mean is y would be your y coordinate, but then m is slope, x is your x coordinate, and b is your y intercept. Okay, notice that we're only concerned with the y-intercept, not the x-intercept, okay? So m is the slope, and b is the y-intercept. You need to memorize this formula. Y equals mx plus b. Okay, y equals the slope of x times x, or the slope of the line times x plus b, plus the y-intercept. So what does that mean? Let's go ahead and see what that means. So if I have a graph, and I'm very roughly sketching these, 1, 2, 3, 4. 1, 2, 3. Let's go ahead and do the same one I did before, where I had going through like this. This is the one I drew on the previous one. Okay, so I'm going to sketch that. Okay, so if we want to put this, find the equation of this line, y equals mx plus b. What we need to do is we need to find the slope, and we need to find the y-intercept. Slope and y-intercept. Okay, so the slope. Remember, we find the slope. Let me switch colors here. We find the slope by figuring out the rise over the run, right? And so if we take this point to this point, because we know it crosses integers there. Okay, so let's see. So the rise is 1, 2, 3. 3. And the run is 1, 2. So the slope of this line is 3/2, and the y-intercept, so where it crosses the y-axis, let me go ahead and switch to a different color here. It crosses that y-axis right here at positive 3. Right? So b is 3. We could put positive there, but we're just going to put 3 because 3 is understood to be positive 3. And so let's go back to our formula now. Oops, sorry. Didn't mean to draw that line there. And so what we have is that we have the slope, and we have the slope, and we have sorry, I'm trying to get back to my normal color here. We have the slope and we have the y-intercept. So now we can write the equation of this line. So the equation of this line is y equals the slope 3/2 times x plus the intercept, which is b, 3. Okay, and so this is the equation of the line. Notice you will not put in anything for y or anything for x. You're going to leave y and x. Why is this? That's because any point you choose on this line, any x that you put in this line, whatever that x is, you're going to get the resulting y. Okay, so your x and y are going to be changing as you go on this line. If we chose this point and we put in this x, we would get this y. Okay, and so that's how it can define the entire line from infinity to negative infinity. So the equation of a line will always be y equals mx plus b in that form. Now, what happens if b is 0? Let's look at what happens if b is 0 and if m is 0. So let me clear this out. Okay, so if we have y, ooh, that's too fat. Sorry, guys. Somehow my pen got fatter. Okay, if we have y is equal to, and let's say that b is 0, mx plus b. Let's say m is 2. Let's give it a slope of 2, and b is 0. Let's see what happens. Okay, so we have y is equal to 2x plus 0. So therefore y is equal to 2x. Okay, y is equal to 2x. So what that means is that it means our y-intercept is 0. Let me switch to a different color here. Our y-intercept is 0. So it's going to cross at the origin there. Okay, and then let's go ahead and plug some of these in. If we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if we put x equals 1 in there, then y equals 2. Here's another point. If we have x equals 2, then y equals 4. If x equals 3, then y equals 6. I'm running into my writing, and we can see that this is creating a line. There we go. Okay, so when b is 0, if there's nothing added or subtracted right here, then you know that that means that your b is 0 and it's going to cross the origin. Okay. What happens if b is negative? Let's look at that. Go back to my other color here. So if we have y is equal to, let's do 1/2 x minus 3. 1/2 x minus 3. What that means is that the y-intercept is going to be on the negative. So it's going to cross here. Okay, and the slope is up 1 over 2. Up 1 over 2. Oops. Up 1 over 2. Okay, and here's our line. Okay, so what this means is that if your b is positive, it's going to cross the y-axis up here, so positive b. If your b is negative, it's going to cross the y-axis down here, negative b. If b is 0, it's going to cross the origin, b equals 0. Okay, so that's how the b affects the equation of your line. Let's look at different slopes. So let's do y equals 1/2 x plus 2. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. Okay, so we know that our y-intercept is going to be 2, so it's going to cross the y-axis at 2, and our slope is 1/2, so it's going to go up 1, and over 2. up 1 and over 2, and then we can connect that. Okay, so this is when our slope is positive. Okay, so that's this one. Let me get a different color here, and we're going to do the same line, but we're just going to flip the slope to negative. Negative 1/2 x plus 2. Okay, so once again, our y-intercept is still positive 2. It's still going to cross the intercept at positive 2, but instead of going up 1 and over 2, it's going to go down 1 and over 2. Down 1 and over 2. And here we have our line. So notice when we flipped that slope to negative, it made it go downhill instead of uphill. So that's how a negative slope affects the equation, in the equation of the line affects the line. Now, what if the slope is 0? Let's see what happens when we put the slope in that's 0. So we have y is equal to 0x plus, let's go ahead and put plus 1 in there. Y equals 0x plus 1. So that is y is equal to 1. And you guys have seen this before. Y is equal to 1. In that case, we know that no matter what x is, y is always going to be 1. So this is the equation for a horizontal line. So if slope is 0, we've already talked about slope being positive this way, positive slope, and we've talked about slope being negative this way. But now we find out that if slope is equal to 0, it's a horizontal line. M is equal to 0. Okay. What about a vertical line? What if we have this, but we have our line goes like this? Let's say it's x is equal to negative 2. Okay, x is equal to negative 2. What kind of slope is that? Well, let's look at this. We know that slope is equal to rise over run. Okay, and so let's go from one point to another and try to figure out what the rise and the run are. Okay, so if we go from here to here, the rise is 1, right? What's the run? How far over does it go? How far horizontally does it move? It doesn't move horizontally. So we have 1 over 0. What's the problem with this? You can't divide by 0, right? That is an impossible problem. And so the way we describe this is we say that there is no slope. Okay, so this is really, really important. If you have a horizontal line, the slope equals 0. If you have a vertical line, it has no slope. Okay, you have to keep those separate. A horizontal line has a slope that is equal to 0, but a vertical line has no slope. Okay, make sure that you understand that and understand the mathematical reason why, right? This one, it's because you can't divide by 0. On a horizontal line, the m equals rise over run. In that case, the rise is 0 and the run is infinity, and anything 0 divided by anything is 0. So whatever you put in there is going to be 0. Okay, so horizontal line, slope equals 0, vertical line, no slope. And that is, let me just rewrite it one more time to summarize how you use y equals mx plus b, the slope intercept form.